So we're standing at the edge of a pretty profound leap in human-machine interaction. Welcome to today's Explainer. We're going to be diving into what is arguably the ultimate flaw in modern artificial intelligence, a flaw that's literally affecting every single automated decision made about you right now. We aren't just talking about pushing software updates here. We are talking about fundamentally redesigning the actual physics of how an AI makes decisions. So strap in, because this is going to completely change how you view the future of technology.
Okay, let's just dive right into the core dilemma of our time. It's actually perfectly captured by Goukassian, who said, "I never believed the problem was intelligence. The problem was intelligence without moral architecture." Think about that for a second. Right now, we're in the middle of a massive epistemic crisis, a literal crisis of truth. And it's all driven by this concept called binary brittleness. See, in standard computing, systems are mathematically forced to spit out binary answers. It's either yes or no, true or false. The AI structurally cannot just admit that it doesn't know something. And when you apply that to incredibly complex human issues, well, it creates a massive and frankly dangerous blind spot.
To really get why this is so dangerous, you have to contrast traditional AI with a huge paradigm shift known as triadic sovereignty. The old way, the traditional binary machine, is structurally forced to guess. It runs on what we call probabilistic collapse. Just imagine an AI trying to diagnose a patient. If it's only, say, 51% sure, it crosses a math threshold and just rounds that perhaps right up to an absolute yes. The machine literally cannot hesitate. It's outputting false certainty. Triadic sovereignty, on the other hand, introduces epistemic warrant. This gives the machine the architectural ability to acknowledge its own uncertainty and actually pause.
Now, what's really interesting about this new architecture is how it uses three distinct sovereign pathways. First, you have a glowing cyan pathway. That's state +1. This is verified action. It means the system has the warrant to safely proceed. Then you have a neon red pathway, state -1. This is active protection, meaning the system detects harm and instantly vetoes the action. But the absolute breakthrough here, that happens right in the center, with the gold pathway, state 0. This is exactly how the new system handles uncertainty.
We call that golden center the secret zero. It is essentially Socratic humility, that age-old wisdom of knowing that you don't know, quite literally programmed into a machine. When an AI hits unresolvable moral complexity, the sacred zero is triggered. And I want to be exceptionally clear about this. This isn't just some polite advisory guideline. No, it is a mandatory, hard-coded hesitation state. The AI stops, it generates a matrix for human review. In this framework, hesitating is no longer a bug or a failure. It's an absolute foundational requirement of the machine's intelligence. Let's move on and see how this all builds together, because the sacred zero doesn't just exist in a vacuum. It's actually the very first of the 8 pillars of constitutional AI. These pillars form a unified, interdependent, load-bearing pyramid. It's a governance-first model, and that's crucial. These aren't optional little features that a tech company can just quietly toggle off to save some money on computing power. If any single one of these load-bearing pillars is compromised or bypassed, the entire system physically and logically just ceases to operate.
Moving up from the base of that pyramid, we hit pillar 2, which is always memory. This dictates that an action simply cannot exist without memory, period. The architecture actually physically blocks any AI action unless a cryptographic log is successfully secured first. You can think of it like an unerasable digital black box. If the logging system fails for some reason, or if someone tries to tamper with it, the machine just halts. It stops cold.
This brings us to a really profound concept summed up brilliantly in this idea. The machine calculates the path, the human signs the map, the ledger holds the ink. This is the iron law of no log equals no action. By enforcing a perfect one-to-one ratio between logs and actions, automated cover-ups become architecturally impossible. Every single deliberation, every execution is permanently recorded in indelible ink long before the action is ever allowed to take place.
But, how do we actually ensure companies don't just pretend to follow all these rules? Well, that is pillar 3, the Goukassian promise. It's a binding socio-technical covenant against ethics washing. We've all seen it, right? When a company uses shiny safety PR to sell products, but they aren't actually constraining their AI under the hood. The Goukassian promise legally and cryptographically binds the operator to the framework's true intent. It stops that PR spin dead in its tracks.
There are 3 core artifacts to this promise. First, you have the lantern. It's a dynamic compliance beacon that proves the operator's intent. Second is the signature, which ensures that when things inevitably go wrong, cryptographic accountability leads straight back to a real human name. And third, the license, which enforces strict structural prohibitions against things like weaponization or mass surveillance. If a company tries to quietly alter those safety vectors just to speed things up, the lantern goes dark, the whole system halts, and the violation is recorded publicly.
So the crucial point here is that this governance actually extends way beyond just human rights. It protects the biosphere itself. Just take a moment to absorb this incredible quote from the architect. The planet has no voice, no vote, no lobby, so we gave her a cryptographic signature and a seat on every AI board. I mean, really think about that. Pillar V6 takes planetary rights and brings them directly into the algorithmic execution loop of our most powerful technologies. This is known as the Earth Protection Mandate. With the Earth perfectly balanced against the laws of ecology, an AI system is instantly vetoed. It gets shifted straight to that red -1 state we talked about earlier if it ever tries to optimize for profit at the expense of mathematically defined planetary boundaries, like the Paris Agreement. The Earth obviously cannot speak up at a boardroom meeting, so this hard-coded mandate literally speaks on its behalf. We are building to a pretty massive realization here. Ternary Moral Logic isn't just some policy document. It is not an end-user license agreement that you can just blindly scroll past and click accept. It is the unalterable physics of governance. See, software layers, they can only promise guarantees, but hardware provides true survivability. As AI continues to scale exponentially, we absolutely have to rely on the fact that electromagnetic conditions are simply not open for negotiation. And this physics is achieved right down at the processor level. Inside the TMPU, running on what's called delay-insensitive ternary logic, governance is baked directly into the silicon itself. Remember the sacred zero? Down here, it exists as a literal physical voltage condition, specifically at half the supply voltage. The AI physically cannot bypass moral hesitation because the electrical current required to act is quite literally blocked until all the governance checks are fully cleared. Which leaves us with this final, profoundly deep question. We've seen how this architecture moves us away from the brittle, forced certainty of binary AI toward a triadic system that enforces the sacred zero. We've explored the pillars that guarantee always memory, the Goukassian promise, and that incredible Earth protection mandate, all of it locked down by the immutable laws of physics. So, if we can actually physically hardcode Socratic humility into silicon, are we finally ready to make conscience the permanent foundation of human-machine evolution? It is a staggering thought. Thank you so much for joining me on this explainer. Keep asking those big questions, and I'll catch you next time.